Swayam Prabha. Digital India. Educated India.
So, we will start lecture 3 of this module, which we initially targeted like damp proofing and insulators. So, we have finished damp proofing in the previous 2 lectures. So, we move into insulation. Now, insulation are of 2 types, that is thermal insulation and also sound insulation. Damp proofing was mainly protecting building from the enemy water. Insulation is protecting building, rather the inhabitants of the building, from temperature. It may be from protecting the people from outside heat or may be protecting the people from outside cold. So, you need to have a comfort condition within the building, that is inside the building. Similarly, think of a hospital or a school. When you are planning for that, you also have to have sound insulation. So, you can always give signs like no horns etc., in front of school, but yes, if it is a noisy road and a school beside it, it will finally give discomfort to the children. Same with the patients. So, you need to know how to insulate a building. First, we will take up thermal insulation. So, we will try to cover thermal insulators and the different types of thermal insulators along with the applications and sound insulation, and also there will be covered some examples there. All thermal insulators are more or less sound insulators, and you will in your course eventually come to a subject which is acoustics, where you will be exposed to sound insulation more, and similarly you will have energy efficient buildings maybe as an elective course in your course curriculum, where you will have further detailed study on thermal insulators. But as a course, as a basic course of building materials, we need to know the materials which are involved in these 2 particular purposes, for these 2 purposes. So, thermal insulators are nothing but materials which will reduce the rate of heat transfer from or to the building. So, the heat transfer will happen from the warmer side to the cooler side, and if we have the inside cool, if we want the inside to be cool, we have to check the heat from outside to enter inside, and if we want our inside hot, we have to avoid our inside heat to get out. In cold weathers we follow that. So, a lot of energy use can be curtailed by appropriate use of material to have a proper comfort condition inside the building, and based on that we need to select our insulators. Gases are very bad thermal conductors. Air is one such freely available, but yes, you can have argon. Where do we use it? Where can we use air as an insulator? We just discussed in our previous lecture, where we had created a cavity. We had learnt hollow block concrete, where we have air gaps or pockets inside the building material. You can have arrangement of bricks in such a way that you can create air pockets. That is again rat trap bond. So, we can cleverly use air infill within a building material and have insulation. Yes, in our country context that is maybe enough, but we also need to know we have to step out of our country, we have to think of minus 40 degree centigrade or maybe plus 50 degree centigrade, and what kind of insulations we need to adapt, because air is not the last choice. Materials having low thermal conductivity will obviously be good insulators. You cannot have non-conductive materials. So, we will have low thermal conductivity, that means the U value of the material will be low and the thermal performance will be better, as insulator will be better. So, U value measures the transmission of heat through any material, and we will try to look into materials which have low U value, that means higher resistivity value or higher R value. We also need to remember material thickness has a role in the variation or the rate of the thermal conductance or resistance. So, thickness of material is also important. In maybe in your higher courses or further courses, you will go into detailed calculations of U value of composite materials, etc., which I am not covering here, but we will move to the different types of insulators. Now, as I have told you, they are bad conductors or better having higher resistivity. We also can have reflective surfaces as insulators. You see here in the list, after the 3 materials cellulose, fiberglass, polyurethane spray foam, we have reflective insulation. So, you see the numbers associated to the materials, that is cellulose and fiberglass, are quite similar. These are the R values. Mind that R values, the units have just reversed. R value is 1 by U value. Whereas, you see that of polyurethane foam is quite high, between 6 to 7. Now, what are these materials? Cellulose is one material which is obtained from, which is organic material. You can see it is a woolly material, grey in color. We will come into the details soon. You see this is fiberglass. It is available in roll form. It is, you can see it is rolled. We have discussed fiberglass in the module where we covered glass. We will come to that again. Polyurethane spray foam, how does it look? It is a foamy material coming out from the nozzle, it is being applied, and reflective insulation. So, if we come to the first one, which is cellulose, it has the least cost of making and least embodied energy in it. It is nothing but recycled newspaper, paper pulp, waste paper, organic waste, and as all these materials are flammable, we need to add boric acid or ammonium sulphate into it, which retards the spread of fire. So, this is having the only disadvantage of spread of fire, and being organic it may be attacked by termites etc. But cost wise it is the least, embodied energy wise, that is production cost wise, it is the least. Now, what you see the application. In this picture you see it is a solid mass, this is a bat, whereas in this picture it is the woolly thing that has come out through the nozzle and has solidified and taken this kind of shape. And what you see in between are these wooden framework. So, once this is pushed in, this framework remains out and you cover it with a say plywood, a finished material, the insulator remains inside. You push in this kind of bats in the framework and you neatly cover it. One cannot understand that there is an insulation embedded in the wall. So, this is fixed and covered, leaving the wall, particularly on the external wall, and leaving the wall insulated. We come to fiberglass. Fiberglass is again nothing but fine strands of glass. We had seen in glass, when we studied glass, that glass fibers are used as reinforcement in GFRG. They are also used in glass fiber reinforced plastic. These are also used as insulators as it contains a lot of air inside it. So, this air is trapped in, and this trapped in air actually acts as the insulator. So, no heat transfer happens, and these fine strands of glass are again discontinuous, and hence heat is not flowing through by conduction through these. You can get rolls, you can get bat forms, and in the similar way as you put in cellulose, you can put in these fiberglass bats or fiberglass rolls. So, this is a dry type of construction which was not for the cellulose when it was not in bat form, available in bat form. It is very easy to install, but remember it is glass strands, fine glass strands, hence they are very unhealthy. If you inhale them, they are having hazardous effect on human body, but however they are having high resistance against any kind of microbiological attacks. So, the health, keeping aside the health hazard, if you can handle this with proper gloves, with proper masks, you can get the maximum out of fiberglass. Similar to fiberglass, we have rock wool, we have mineral wool, we have slag wool. They are all having similar kind of R values between 3.5 to 4, and these are obtained by heating stone. You get rock wool, you can get mineral wool in similar way. You get slag from iron ore from different mineral industries. You can actually heat them at 3000 degree centigrade and then pass in under pressure, pass in air through it, and you can get rock wool, mineral wool, slag wool, etc. So, as I told you, similar to fiberglass, their R values are very close, and amongst these few you find that cellulose is the cheapest, cellulose is the most easily available having less embodied energy, but application wise fiberglass is the easiest. Now, we come to polyurethane foam spray. As I told you, it has a high R value of 6 to 7, and why? It is because of the low conductive gas chlorofluorocarbon entrapped within it. This is a thermosetting polymer having a closed cellular structure and available in foam form. It may be flexible, it may be rigid, but because of a different gas being entrapped, it is having a different R value much higher than that of the conventional insulating materials. So, we need to know where we are going to apply it. If it is a very cold country, you have to go for such kind of foam spray, because it will finally help in reducing the further energy consumption. Other than these, we have extended polystyrene, that is commonly known thermocol. We have extruded polystyrene, which are also used as insulating materials, and we can actually put them into the external wall by putting a framework and embedding them and then neatly finishing it with a coating. It may be a plywood piece, it may be a metal sheet, you can actually cover it and make your house insulated. We now move to the reflective insulation. As I told you, you are reflecting the heat, the radiation from the surface. You can see in the picture, one is a metal sheet with a backing. You can see this here, these are all reflecting surfaces. Here this is glass, which is again having a metallic coating on top of it, onto which the solar energy, when it is falling, the heat, when it is falling, the radiation is reflected out. So, the surface reflects most of the thermal radiation, thus preventing the heat to enter into the building. So, this is the basic principle of reflective insulation. Where do we put this reflective insulation, this metal sheet? We have, you can see these are all put in pipes. These pipes may be the air conditioning ducts, where the cold air needs to move from one place to another, and there you do not want the outer heat to make the inner cold air warm. So, that is why these pipes are coated with this metal sheet, which is which also has a backing, and these are usually aluminum foils. Now we come to sound insulation. You see very similar picture, the third one, the rock wool, the fiberglass, which is similar as the fiberglass. Other two pictures what you see is cork sheet, you see straw boards. These are also thermal insulators. Now, what is there? Air is entrapped in these particular materials, and which is not allowing sound of specific frequencies to get or create any disturbance. So, particular application of the sound insulating materials are specific for specific frequencies. They may be of different thicknesses for absorbing different frequency sound. So, it is not only the material, but also the material thickness. As in case of thermal insulation, it was differently affecting, the thickness was changing the U value or the R value. Here also the frequency which of sound that will be absorbed will also be dependent on the thickness of the material. You see cork sheet, you see straw board. You had seen cellulose as thermal insulator. Here you see cork sheet, straw board, they are also organic materials. They have air pockets inside it. The sound of specific frequency actually gets trapped in these particular materials. They are spaced between inner wall and inner side of the wall, that is wherever you need that acoustical absorption, sound of specific frequency absorption, with or without an air gap with the main wall, and they may be suspended from ceiling or they may be fixed to the ceiling, they may be fixed to the wall also. So, in all cases they will be absorbing sound, but they will be of different frequencies. So, you see the summarizing line, different thicknesses of porous absorbers absorb different frequencies of sound, and again different distances between the inner side of the wall and the material also helps in different frequency absorption. You can see some pictures here. As you see here in this picture, this is the fiberglass embedded. Here are the air gaps, these are the air pockets, and it has been kept in place by these wooden studs. So, this was a void entirely of air into which this mineral wool or fiberglass has been pushed in, and on top of it you can see a coating has been applied. Now, this coating can be plywood, as you can see it is written boards. It can be perforated board as you see in this picture, or it can be perforated metal sheet as you see in this picture. So, the inside is the same insulator, that is the fiberglass or the mineral wool or the cork sheet, but on top is a layer. On the other side it may be the wall or again a board or a lining or the finishing layer. It may be a separating wall between two classrooms also, so that sound from one side does not move to the other side. And the covering is also very important. It may be a plywood, which is a solid panel, it may be a perforated metal panel, it may be a perforated board. In all the cases, they are acting as allowing different frequencies of sound to get absorbed by the mineral wool which is placed inside. We see some different kind of sound insulator, which is slat resonators. You see, these are wooden pieces fixed on a wall, which is fixed on a surface which is again separated from the main wall by some air gap, and these studs, these supports, the slats, wooden slats are allowing some sound to get trapped into the gaps in between the slats. These are called slat resonators. You can have similar kind of thing developed by concrete. This can be a precast item of concrete which will have such kind of pores or holes or voids which will trap in specific frequency sound. So, these will act as sound absorbers or sound insulators when we know which particular frequency we need to trap or we need to insulate or absorb. We will choose a type of particular insulator or particular material to do the task. So, once we get into detailed calculations, details of this in another subject which is architectural acoustics, you can actually find out which material will fit into when it is a musical performance, when it is a lecture performance, when it is a particular classical music or a dance performance. So, depending on the type of performance, the frequencies will be generated and that type of frequency will be required to be insulated or trapped in. With this, we finish the insulation part of this particular module. So, we are looking forward for some more materials, maybe composites, gypsum, etc., as a continuation of this particular module. Thank you.